Stephanie Washer here to talk about IPv4 addressing. It's Module 11 in the Introduction to Networks version 7 Cisco Networking Academy curriculum. And we will be talking about the address structure of an IPv4 address. So we've got network host portion and subnet mask. We're going to talk about the differences between unicast, broadcast, and multicast. We're going to talk about all the different types of IPv4 addresses, public, private, and so on. Then we'll talk about network segmentation. And then in a whole separate video, we'll talk about subnetting an IPv4 network. So the first topic is IPv4 address structure. And an IPv4 address is broken up into two parts, the network portion and the host portion. So with an IPv4 address, we have 32 bits total for the address. So you can kind of see here in this address, we have 192.168.10.10, and we've got 4 different sections separated by a dot, and each one has 8 bits, so we call it an octet. So you're going to hear me use the term octet a lot. So the first 3 octets are the network portion, it tells us here, and then the last octet is the host portion. Generally, what tells us which is the network and which is the host is the subnet mask. So when the router gets an IP address with a subnet mask, it will look at the subnet mask to determine what the network portion is. So, and then it'll know where to send it onto the network. So here is a picture of the subnet mask with the network address. So you can see that the subnet mask is 255.255.255.0. So wherever there is a 1 is the 255. So we've got all ones in the first octet, second octet, and third octet. So it's just the highest number in each octet, 255.255.255. And then .0, of course. So we're actually going to use a process called ANDing to figure out what the network address is. So we will take, it's basically 1 plus 1 is 1, and then 0 and anything is 0 is basically what ANDing is. It's more like multiplication instead of ANDing, and that's what the router does. It takes the network portion, network address, and the subnet masks. It ANDs them together to figure out the network address. So what we're going to do is we're going to look at the prefix length. So when we're looking at the subnet mask, we actually have a prefix length that we can use to kind of determine what our subnet mask is. So sometimes you'll see this on the curriculum where it'll be 192.168.10.10/24. And that is just tells us how many ones are in the subnet mask. So this is just a chart, and it kind of shows you the prefix length. 8 ones is a /8. This one happens to have 2 octets of ones, which is 8 plus 8 is 16. And then this one is 8 plus 8 plus 8 is 24. So, and then we just kind of add, then we added by 1. So in this class, the ones that we'll use a lot are the 24 through 30. We'll use 8 and 16 as well, but the 24 and above are the ones that we're going to use a little more. And we call it the / notation, prefix, but it's the number of ones in the subnet mask. So it's the number of bits in the subnet mask. Now, if we go and we do what is the actual ANDing process, where 1 and 1 is 1, and 0 and 1, 0 and anything is 0. So 0 and 1 is 0, 1 and 0 is 0, and 0 and 0 is 0. So 1 is true and 0 is false. And it's kind of like our on and off binary bits, right? So you look through this and you see 1 and 1 is 1. So honestly, if it's 255, the number is going to be exactly the same. And then this one you'll notice exactly the same. This one you notice it's exactly the same. So when it's all ones, you just bring the number down. It's just nice and easy. If it's all zeros, it just ends up being a 0. The difference comes in when you have like a number like 240 or a different number like that, and you could have a different network than a different network address than IPv4 address. So this is just logical ANDing. And you just go bit by bit. But the easy way is if you've got all ones, it's just going to be the same in that octet. So we're going on to network, host, and broadcast addresses. So within each network, there's 3 types of addresses. We have, obviously, network, host, and broadcast. And when you look at your network portion, do the ANDing, you find out your network address. And so we found out the network address before, and it was 192.168.10.0. And if we add 1, we know that that's the first network address. So 192.168.10.1, we just added 1 to, and it's not a binary one, we added a decimal 1 to it. And then to find out the last address, generally what I do is I find out the broadcast address first, and then I subtract 1 to find out the last address. So I know that the broadcast address is going to be all 1s in the host portion. So in this instance, it's all 1s in that last octet, which would be 255. So the broadcast address is 192.168.10.255. Then you subtract 1, and you've got 254 for the last address. So that's generally what I do. I always find the network address and the broadcast address, and then I add 1 for the first address, and I subtract 1 for the last address. So you can see that we add 1 to the network to get the first address, take away 1 from the broadcast address to get your last address. And then you can assign numbers however you feel, or however the lab tells you. So sometimes the lab will tell you specifically to put the router as the very first address and the switch as the second one. And then you can just number them however you wish. All right, on to unicast, broadcast, and multicast. Unicast is just 1-to-1. So it's one packet being sent from like a computer to the destination, which is another computer or a printer or whatever you're doing. So in this instance, we have the computer at 172.16.4.1 going out across the network, well, across the switch, basically. Going across the switch to the printer, and that's just 1-to-1. So it knows, we've got one source and one destination. When we have broadcast, it's 1 to everybody. So we have an example here of our 172.16.4.1 is sending out to everyone on the network. And it's broadcasting even to the router. So the destination is 255, 255, 255.255. So it's 4 255s. On to multicast, where it's 1 to many. So we're sending multiple packets. So again, PC 172.16.4.1 is sending out a packet to a group of computers using the address 224.10.10.5. And it just sends to multiple computers. Types of IPv4 addresses. Public and private. So we'll go over the difference between public and private. And private IP addresses are ones that cannot be routed across the public network. So we've got a chart here of all of the private address ranges for IPv4. And 10, basically anything 10 dot is private. So we've got 10.0.0.0, and they did a /8 for the subnet mask to show you that all of them. So anything with a 10 in the front, in the first octet, that's a private address. Then we have 172.16.0.0/12, and that is going to be just about anything with a 16, well, anything with the 172.16 all the way up to 172.31. So any addresses in that range. So you can see here 172.16.0.0 through 172.31.255.255. And then 192.168.0.0/16. So we can have any 192.168.0.0 all the way up to 192.168.255.255. So we have a long range. Private IP addresses are not routable. They cannot go across the network. what we have is network address translation. So because we don't have that many IPv4 addresses, we know this. We use public and private IP addressing to help us kind of conserve IP addresses. So we have what's called network address translation that the router will do, and it will take a private internal IP address and make it a public IP address. So, you know, that router is the one that typically does it. So it's right there on the edge. It's called an edge router that connects to your internet. And it does all the translation for you. You don't even know it's happening. So other addresses are the loopback address and the link local address. So the loopback address is just what you're going to use to test your network card. So basically you commonly use that with ping. So it's ping 127.0.0.1. And it's just making sure that your TCP/IP stack is operational. And then the other thing is what I want to kind of reiterate here is when you use ping, you want reply here, and then you want this bytes. You don't want to say destination unknown because that's not destination host unreachable. That's not correct. Link local addresses. When you get this, that means you're not getting your IP address from a DHCP client. So if you have your IP address listed as automatically obtained, and you don't get information from DHCP, this is the address you'll get. And you never want to see this address. It's not one that you want. So it's also known as the automatically private IP addressing. And it's just what Windows uses to throw an address on there when there are no DHCP servers available. In the past, we used to use this classful addressing, and it's still kind of stuck in my brain because I always think whenever I see a /24, I'm like, oh, it's a class C. So in the past, we had class A, class B, and class C that we would use for IP addressing. And we had /8 for class A, which was 255.0.0.0. Class B was /16, which is 255.255.0.0 for our subnet mask. And then class C was our /24, which is 255.255.255.0. So when you go in and you put an IP address in Windows and you type it in and then you click on the subnet mask, sometimes you'll see a subnet mask pop up. That's going to be your default subnet mask. So it still kind of does the default subnet mask for you. So sometimes you're lucky and it puts it in correctly, but you always want to double check that. And then class D and E, those are reserved, and we'll talk about that in a minute. So class A has 128 networks, but it has 16 million hosts per network. And then class B has 16,384 networks, but we have 65,534 hosts per network. So these are hosts per network. And then finally, class C, we have the most networks. We've got 2 million networks. And then we have only 254 hosts per network. So really, you know, you got to figure out how many computers you have and how many, you know, if you can break up your networks, that would be great. But if you have a small business, a class C, it just works just fine. And the IP addresses are assigned by the Internet Assigned Numbers Authority. And we've got all sorts of different IPv4 and IPv6 addresses, and there's 5 different regions, regional internet registries around the world that are responsible for allocating IP addresses to ISPs. Network segmentation. So network segmentation is just when a packet is too big, we're going to break it up. And most packets are too big. So we have the protocols that use broadcast or multicasts, and those switches will propagate those across the network, right? So when we talk about broadcast domains and segmentation, when we look at switches gather information and then propagate those broadcasts. So if somebody sends out a broadcast, they're going to propagate that broadcast out all interfaces except the one on which it is received. And really the only device that stops that is a router. And so that router will stop everything, and they will not propagate a broadcast message or a broadcast. So it's all, so this router, you can see this is a broadcast domain, and we used to have where you would have to circle all the broadcast domains and all the, the different segmentation, how it works. But we don't have that one anymore. So problem with a large broadcast domain is you've got too many broadcasts that are going across the network, and that can bog down the network and negatively affect it. So to reduce the size of your network or the broadcast domain, you just create smaller ones by using subnetting, and you just use a router in between. So see how we went from a router here, we just broke it up and put our router in between. And so we had 2 different ports, and we can have 2 different LANs and 2 different broadcast domains. And these are, we're not talking layer 3 switches here. We're just talking layer 2 switches. So we've got the router, which is a layer 3 device, breaking up this. And what we did is to reduce this, then we took the number that we were given, and honestly, it's just a private IP address. So we're taking this private IP address and we're going to create 2 different subnets. And I'll show you how to do some subnetting later, but we broke it up into 2 different subnets, and we've got 172.16.0.0, and then the next network is 172.16.1.0. And now we've got 200 users per network, and the broadcasts are so much better. So why do we want to segment the network? We want to make sure that we have the best performance possible. So we want to, reduce that network traffic, reduce the number of broadcasts over a network, and improve our network performance. We can also have different security policies on the different subnets. And if something happens on one of the subnets, we have less equipment that it might affect. So you can subnet items out. We can subnet it by location. So this one shows you an example of it's subnetted by floor. And then we can, or we do by function or group. And then this one is by department. And, and then this side is by group. So if we're at a school, it could be students, faculty, and administration. This one is department, human resources and accounting, or device type. So we have LAN, one LAN that's all of our hosts, one LAN is all printers, and one LAN is all servers. So that you can just have different subnets for different reasons. So that was the quick IPv4 lesson, and in the next video we will be talking about subnets. If you have any questions, you can always email me at s.washer@rockvalleycollege.edu.